All right, thank you for watching. So today you guys have a sub. Hopefully you've already gotten your laptops and you're watching this on your laptops. Great. So we have an assessment on Monday and I'm going to go over answers to the review. So hopefully you have attempted it first. Um, so first warm up, we want to solve for y. So take a minute. If you haven't solved for y yet, do that now and then hit play. I guess I can do one. This one looks exciting. Let's try this one together and then I'll ask you to hit pause. Okay, so I see two values of y, so I'm going to get those together. So maybe I subtract 2y from both sides. And here I get 3y. There we cancel out because a positive and negative 2 add up to 0. All right, I want the y's by themselves, so I'm going to move the 8 over here. I'm going to subtract 8 from both sides, and notice I put it under the 5 because it matches up. That cancels. Here I still have the negative 3x, and what is that, negative 3? Then I want to get y by itself, so I need to divide by 3, and I divide each term by 3. So y equals negative 1 over 1, so it just simplifies to negative x minus 1. That would be solved for y. So take a minute, solve these for y if you haven't already. Hit pause if you haven't. The answers will pop up in just a second. All right, go ahead and check your answers. Hopefully you got those. If you made some little mistakes, I imagine like negative divided by negative, that simplifies to a positive, and that's really a 1 on top, so it's 1/2 x. All right, homework tonight is to finish Unit 4, Topic 4, the formative review. Watch this video and hopefully get some questions answered. All right, I will be here early on Monday morning if you have questions that still need answering. All right, here are the homework answers. So I'm going to ask you to pause this. I'm not going to stay here very long, so pause it so you can check your work. And here is the other page. Great. So notice on every single triangle that we're classifying, we need to find all 3 side lengths, and we need to check their slopes to see if there's a right triangle or not. All right. So a couple notes. Make sure you're looking carefully at the scale of the graphs and round your answer to the nearest hundredth when necessary. Okay. So this is like from day 1, right? You guys got some good feedback on the quiz. Many of you did really well on this. So we have 5-to-1 ratio. We need a total of 6 parts. We need to break this length, the height and width in a sense. If we look at this as a triangle, my line is not very straight here. Sorry about that. Okay. We want to figure out, okay, this is 10, this is -8, so this is 18 units long, and actually we went down 8, right? And write how much? 1 over, and how many this way? 5, so a total of 6. So our slope is -18 over 6, and if I want to break that into 6 parts, I'm going to divide the numerator by 6 and divide the denominator by 6, and we get -3 over 1. So that tells me my little part. Now here it's saying from P to U needs to be 5 sections. I'd rather count 1 section, so I'm going to go up from G. So I'm going to go up 3, 1, 2, 3, right? Every 2 boxes is 1, 1, 2, 3, over 1. Whew! Okay, so I would say this is U. I would double check, is this 5 parts? Is that 1 part? It is. All right, cool. So that was our point U. And now we need point I, so the ratio is 2-to-1. So I need to take that same slope and divide it by 3 this time. So -6 over 2. So I would need a 2-to-1 ratio. Down 6 over 2. That's 1. Down 6 over 2. That's 2. And I need a 2-to-3 ratio. I'm sorry, 2-to-1 ratio. So here's my 2 section. Here's my 1 section. Starting at P, Pi. So the coordinate here would be -1, -2. And for U, it would be 0, -5. All right, it's important that we read the directions. It says determine the coordinates, so we want to make sure we're giving those coordinates and plot the points. Cool. All right. That is another way of looking at it. It's about the same way of looking at it. Okay. Here's another one for you to do. Take a minute, pause if you haven't done it yet, try it on your own. Notice this word explain. Okay, so we had to have the same slope and it had to be through that point, -210. So this point right here, we want to take the same slope. I plotted that point and then I counted out the slope of -3. Down 3 over 1, down 3 over 1 until I found the y-intercept. Then you could write the equation of the line. So this is the equation of the line. You could have also used the point slope formula, right? Use your formula sheet, plugged in all the pieces you knew, and you would have gotten that same equation. Great. All right, this one is asking for perpendicular. Take a minute, think about the slope. Think about vocabulary words. Perpendicular slopes have what properties? Let's try to use proper language. All right, so slope is perpendicular. It has the opposite reciprocal slope. Opposite reciprocal. The original slope was -3 over 1. I make it the opposite of negative is positive. The reciprocal, sorry, that's an I, reciprocal, is 1 over 3. All right, great. Okay, this is the new exciting stuff. Find the area and perimeter of the figure below. Okay, so area, perimeter. So perimeter, we don't need this section. We don't need this section, right? Perimeter, we're only taking, let me highlight it, we're only going around the outside of the figure, right? So that is the length, those are the lengths that I need to figure out. And some we can just kind of figure out, right? Here is, they're both on 20 in the Y, but 2 and 15, I can say, oh, that's 13 units from here to here. I'm pretty sure this is not drawn to scale. Then 15 to 25, this point right here, well, we can figure out, well, that's just 10 units right there. Okay, so we've got 10 units and 13 units. We've got to figure out that diagonal, so we could use distance formula to find that length between those 2 points. Y2 minus y1 squared plus x2 minus x1 squared, and then square root that, right? I can find this distance pretty easily. 15, again, not drawn to scale. All right. Here, so these vertical and horizontal distances we can find pretty simply. 20 to 50, I went up 30 units. Here, from 10 to 20, that's 10 units. So really, it's just these diagonals that I need to figure out. Okay, so let's go ahead and do one of these. So I'm going to say x1, y1, x2, y2, and we're going to use the distance formula. So we don't have labels, but if this was like A and this was B, I'm going to say, okay, the distance of AB, that length, is going to be the square root of some quantity squared plus another quantity squared. Really, this is the Pythagorean theorem, just solved for the hypotenuse, or C. Okay, so we are going to do x2 minus x1, so I'm going to say 30 minus 25. The difference in those, and then the difference in your y's, 10 minus 20 is 10 minus 20 is -10. But the negative doesn't really matter because we're going to square it. Here we get 5 squared. All right, 5 squared is 25. 10 squared is 100. Square root, so the square root of 125, which is not 15. Okay, so we don't say 10 and 5. We have to add it together before we take the square root. So we can approximate that. All right, then you'd want to find the distance here and then add all of those pieces together, right? When we're finding the area, we're going to find the area of 3 different sections. 1, 2, and 3. So we find the area of the rectangle. So 15 times 30, right? That would just give me base times height is the area of the rectangle. Then base times height cut in half for this. So this height would be helpful. 20 to 50 is 30, right? 1/2 base times height would give me this. And same thing there. All right. So I don't see units over here. So just be careful. This is units squared. These are areas. So make sure in our answer that we're finding those areas. All right, so here, the area of the triangle, 1/2 base times height, area of the rectangle, area of the triangle, 1/2 base times height, and the total area is the sum of all three of these added together with units squared, right? The perimeter is adding up all those little pieces that we looked at, and that's what we end up with. And that's just units because it's just a distance. All right. Oh, here is that on the calculator. So it's approximately, right, that's the square root of 125. All right. Great. Look at the line K, whose equation is x equals 3x minus 2. Okay, minus 2 is our y-intercept, and we rise 3, run 1. Write the equation for the following lines. A line parallel to K that passes through that point. So 0, 2. You can either do this graphically, visually, 1, 2, 3 over 1, 1, 2, 3 over 1, and do it that way. So here, that is my y-intercept. So it's going to have the same slope, and that y-intercept. That would be parallel to the line passing through that point, 3, negative 3, 3, negative 3, and it's parallel, rise 3, 1, 1, down 3, back 1, down 3, back 1, down 3, back 1. Uh-oh, where are we? Okay, so here we're at negative 6, 7, 8, 9, that's at negative 9, 10, 11, 12, negative 12. So here I would say the y-intercept is negative 12. Now you could do that algebraically. If you wanted to, because if you're not comfortable with it going off the graph. So what you could do is you could say y minus a negative 3 slope x minus 3, right? So what I did is I plugged into my point slope form. I plugged the y coordinate here, the x coordinate there, remember they're opposites, and the slope. I'm going to distribute 3x minus 9 equals y plus 3, subtract 3, and we get negative 12. Awesome. It's nice to see that I got a little confirmation. So if you ever aren't sure of something, you have extra time, go back, do it a different way. All right, then we have perpendicular. So our original slope was 3. So if my original slope is 3, I need my perpendicular slope is going to be opposite of positive 3 is negative 3. And reciprocal of 3 over 1 is 1 over 3. So negative 1/3 is my perpendicular slope, and it needs to pass through that point. Well, that point is the y-intercept. So y equals negative 1/3 x minus 5. Didn't have to do a lot of work because that's the y-intercept. Here, maybe we have to do a little more work. Y minus, I'm going to just do it algebraically, minus 4 equals the slope, negative 1/3, the perpendicular slope, right, times x minus 3. All right, distribute that in, negative 1/3 x, multiply there, we get positive 1 equals y minus 4. Add 4 to both sides, and we've got our equation of our line. Okay, cool. The answer keys on the next page, we'll just double check. This is another way of approaching it. So some other people suggest you use slope-intercept form. If you're more comfortable with that, that's great. Just make sure once you get your b value, plug it back in to give me the actual equation. All right, cool. Here's a couple more. We've done some of these, so pause real quick. I'm going to jump to the answer. If you haven't done it yet, try it. Make sure you're okay. All right, that is that. Make sure you're giving the coordinate if we ask for it. And another one, this needs to be perpendicular. So it passes through that point. Again, you could do algebraically or visually. And here is that answer. And one that's parallel that goes through that point. So find the slope. Again, you could do algebraically or visually, graphically. All right. Great. So find the area and perimeter of each figure below. This first one is really simple as far as area. I could just count every single square, or I could break it up into little parts and say this is 4 by 1, 2, 3, 4, 5, 6. 4 by 6. I could multiply 1, 2, 3, 4, 5. 5 by 6, 7, 8, and just find the area of this section, the area of that section. I can find the perimeter pretty quickly by counting the distance all the way around. It's important that we get all those pieces. Let's say I had a chunk out right here. Right? I have to be careful to go around if there's some chunk taken out. In this case, there's not. Okay, so we're just going around the very outside of the shape. That is our perimeter. It's like a piece of fruit. It would be the skin on the fruit. Right, like an apple skin or orange peel. All right, that is our perimeter in this case. Now in this case, I would definitely suggest break it up into two sections. You've got your triangle and your rectangle. So we've got the hypotenuse. You need to use distance formula. Sorry, that's not really your bell ringing. That's my bell ringing. All right, here are some answers for that. So be careful with your units. Area should always be units squared, and perimeter is just linear units. All right, another one. Okay, so we're given coordinates. We got to think, okay, how much did I move to get from here to here, or use distance formula? This might take a minute to see all the different pieces, right? So we're doing 3 different areas and then adding the 3 areas together. Here, perimeter, we're adding all the little pieces on the outside. All right, thank you so much for watching the video. Please keep reviewing, go back, look at every page of your packet so far, practice these problems. All right, thanks for watching.